Hey everybody, it's Miss C. So, in our little basic drawing series that we've been going on, yesterday's little lecture was on contours of flat-sided objects. Contours being ways that we can figure out how many shades of gray we need in an object. And contours are the surfaces like curves and flats of a surface of an object. All objects have contours. Your face has a contour, tape has a contour. We have contours around here on this little cylinder. And yesterday we went over everything that was flat. Pyramids, cones, pyramids, rectangular prisms, and cubes, because they're easier. They're flat. It's easy to figure out. Today we get to go over the slightly more difficult ones, anything rounded. What you're going to start with today is drawing a cylinder, a cone, and a sphere. Yours do not need to match mine. It will make some of your life easier, but it's not necessary. I'm going to start with my cylinder. I'm going to draw him like so. You should have notes on how to do this yourself. You should not need my guidance. Betrayer. All right. So we're going to start with our cylinder over here. Now, if you look at the cylinder, there are some parallel lines that you can follow. So if you were thinking about drawing these lines or like a grid onto the surface of your cylinder, you would probably draw lines going straight up and down, following those parallel lines to the sides. So we're going to do the same thing over here. We're going to start with some parallel lines. Remember that they do not matter for how many, if they're evenly spaced, or the number of them, things like that. What matters is that they are in the direction that they are going. In this particular case, vertically up and down to be parallel with these sides. Now the next one that we do would probably be lines that went around the outside edge. So, like so, that ring around the rosy, so to speak. But whenever we're drawing this cylinder, those are not straight lines. You'll notice here, this is on level with that. That's still straight. But on here, we've drawn it as a curve because we're seeing this at a slight angle. The same thing is going to happen on our little grid here. We're going to see all of our lines that go across as curved lines that match our top curve right here, which also matches our bottom curve down here, because this oval and this oval that we can't see all of are the same size and shape oval. So what you're going to see most of the time is that kids will see their curve, and then some of their curves will end up more flat or more curved than the original one they're trying to match. So don't do the wrong curve. Always try and match it. And again, it doesn't matter if that curve is, if there's many or a few, we just want them all to look the same. So over here on the side, we've got verticals and curves, like so, making up the lines. On our top, there are no parallel lines for us to follow, but it is still a flat side. So we're going to end up with a grid like we have on the cube or the rectangular prism or the bottom of a pyramid. But how do we get there? The fact is you already kind of have an idea of how to get there. And if you think about how we drew a cone, when we started a cone, we started with our oval, and then in order to find out where the point was, we drew two lines. We drew from the furthest away points and attached, and the closest together points, and we attached. And that's how we found our center to draw the point of our cone. Use this same thing to make some lines that you can have parallels to, because you can't have curves parallel to one another. It just doesn't happen. So across that full length, from shortest edge to shortest edge, right there. And honestly, because direction is all that we need, this could be enough, or you could have some lines parallel to those to make our little flat. Same thing applies over here. Those are our grids. So on our top side, our lines are verticals and horizontals. Be aware, this one and this one are not the same grid, because when we're looking at this on a 2D plane, these vertical lines are, these have no vertical lines. These are two different diagonals, but the entire cone is tilted, which is why they appear vertical and horizontal if you were to righten the cone. But since it's tilted over, this and this do not match. They are different grids. Just keep that in mind. All right, now for the rest of the cone, if we look at our cone, we do still have straight lines on our cone. They're the lines for the sides, right here and right here. But they are not parallel. They all meet at the very top. So our first set of lines on this part of our cone will do exactly that. It's like dividing a slice of pizza into lots of pieces. We're gonna have lines that go and meet at the tip. And then you think, okay, so now I'm gonna have the curved side with the curved lines that match each other. Here's our little circle that matches the outside edge of our little guy. And if we were to have that same curve elsewhere, higher up on our cone, he don't fit. What would I need to do with this to make him fit higher up on the cone? I just need to make him smaller. Same thing with these curves. You're going to make them smaller. So here's what kids want to do. They say, I see, I want a smaller curve. So they take all their curves, and they draw them going down in whatever direction they need them to go. Yes, I know. And then they just chop off the ends. They're like, okay, it's smaller. Don't do that. No. It's like you're zooming out on a photograph. Everything gets smaller proportionally. So if you have a curve, the next smaller is the same curve but smaller. The next curve is the same curve but smaller. The next curve is the same curve but smaller. They just shrink. So over here, we're going to be matching this curve right here. And it just gets smaller as we go down. And again, on a regular cone, that would just look like rings going around it. All right, very last one is our sphere. A sphere, no matter what angle you look at it from, is the same looking. It does not tilt in funny directions. It is always a circle. Which means that adding a grid to it can always be done the same exact way. I like to think of the grid as something that can be tilted along with the circle, but that's because my brain wants to put one end of this circle towards the light source all the time, and it helps me visualize shadows. But if you're not at that level yet, that doesn't make sense to you, you could do this the same way every single time. So I'm gonna show you the super most basicest way that I know how to do this, so you can do it the same way every time as you need. And basically what I'm gonna have you think about is a globe. On a globe, you have like America over this way, like Mexico and Canada, and then Europe over here somewhere. We have lines that help us tell your phone, the world, where you are at. They're longitude lines and latitude lines. Longitude lines go this way, latitude lines go this way. So longitudinal lines go from North Pole to South Pole, and they meet at the North Pole and the South Pole. So when we draw them on our sphere, you're gonna have one line that splits it in half, and more lines that go around, but always touch your North and South Pole. And again, the number of them doesn't matter. What matters is that they're going in the right direction. And the thing to remember is that the further out towards the edge they get, the more bendy they are. Now, how dare you? For the rest, the lines go straight around the outside, but just like they do on our cone, they get smaller the higher up they are, because this doesn't quite fit. It's like a bunch of concentric circles. If I were to tilt it so that the North Pole was facing you, it'd be like a little target. And drawing this part is hard, so forgive yourself if you're not so great at it. I forgive me. I'm gonna have a line that splits it in half. If this were a globe, that'd be the equator. And then I have a few more lines that still curve around, but not so hard because they're not meeting anywhere. Curve, curve, curve. These are much less curvy. Still a curve, but not quite the same. All right, so now we have all of these different contour grids for these different shapes. And again, if I had these shapes in a drawing, what I would need to remember for shading is this. Erase you, give yourself a little star. What I want you to write is, if the contour grid is curved, has a curve, just sounds better that way. If the contour grid has a curve, the shading will be a gradient. If you don't remember what a gradient is, it means multiple shades. And that's everything you need to know about contours on curved shapes.